Hello, I'm going to do some problems here from 4.1, numbers 47 and 49. It says for each of the following polynomial functions, describe the behavior of its graph as x goes to positive or negative infinity, and identify the x and y intercepts. Use this information to then sketch the graph of each polynomial. Okay, so we have the negative out front, so that's our leading coefficients at -1. X minus 2 times x plus 1 squared times x plus 3. So we're going to have x, this will give us an x squared, and x, that's x to the fourth power is what we have here. As I was saying, x times x, this is x squared, x, that's going to give us x to the fourth as a general kind of class that this is. We know x to the fourth will start high and go high if it has a positive leading coefficient. But this has a negative leading coefficient. So that means it's going to come from below, do some stuff, and then go back down again. Okay. Now we have some behavior in here. We have the following x intercepts. X minus 2 equals 0 is where x equals 2. X plus 1 equals 0 where x equals -1. And that's a double root, so that means it'll just touch at the -1 and go the other direction. It's not going to pass through. X plus 3 equals 0 means x equals -3. As far as y-intercepts go, that's where x is 0, so f of 0 is negative of 0 minus 2 times 0 plus 1 squared times 0 plus 3. That's going to be -2 times, I forgot the negative out front. Negative of -2 times 1 times 3, which becomes positive 6. 0, 6, 6. And over here we had 2, 0, -1, 0, and -3, 0. Okay, so the end behavior is as x goes to positive infinity, this goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. So I should write that down. As x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity as well. So a rough sketch here, we know it's going to cross at, it's going to touch at, let's see, 1, 2, 1, 2, 3. Label these 2, 1, -1, -2, -3, 2, 3, 4, 5, 6. I should probably stick the same pacing. 1, 2, 3, 4. Okay. So we know it's going to cross at 2. We know it's going to cross at -3. It's going to touch at -1. We know it also crosses at 0, 6. So it comes from below. It's going to come back down, touch that, go up, and then go up like maybe like this, and there. And there's our rough sketch of the graph. And I know you can graph this in the calculator, but what I'm after is you understanding the behavior here and what's happening with this, why it's this way. So hope that helps. We have one more to do like this, 49. We have f of x is 5x to the fourth plus 6x cubed minus 25x squared minus 30x. And I would, because we have 4 terms, I'd factor by grouping. I mean, we could immediately see that we could pull 5x out of everything if we wanted to. No, we can't pull it out of that one. Okay, so f of x would be 5x to the fourth plus 6x cubed minus 25x squared plus 30x. And I can just hear people yelling, wait, that was a negative, Jeff. Yeah, I know, but we factored out the negative here. That changes this to a positive. So the negative of 25x squared is negative 25x squared. Negative of 30x is negative 30x. So our f of x is x cubed times 5x plus 6 minus, from here we can factor out a 5x. What we have left is a 5x plus 6. So f of x is going to be x cubed minus 5x times 5x plus 6. I'm going to take this one more step. F of x equals x times x squared minus 5 times 5x plus 6. So once I have this in factored form, and I just try to get myself more space here, I hope it's easy to see that the x-intercepts are going to be x equals 0 from there. X squared minus 5 is 0, means x squared equals 5, which means x equals plus or minus the square root of 5. That's two of them. 5x plus 6 equals 0, so 5x equals negative 6. So x equals negative 6 over 5, or negative 1.2. So we have 0, 0. We have square root of 5, 0. We have negative square root of 5, 0. And we have negative 1.2, 0. And just to give the give it some, I don't know, a little more relevance, square root of 5. What is square root of 5? It's 2 point what? Square root of 5. 2.23. So again, 0, 0. Let's say 2.24, comma 0. Negative 2.24, 0. And negative 1.2, 0. So those are our x-intercepts. Coincidentally, I mean, I shouldn't say coincidentally, but also this is a y-intercept because it does cross the y-axis, and we're not going to have more than one y-intercept for a function. If you want to test that, the y-intercept occurs when x is 0. So f of 0 is, let's look at the last factored form, 0 times 0 squared minus 5 times 5 times 0 minus or plus 6. Well, 0 times anything is 0, so 0, 0 is the y-intercept. A couple other things is the fourth power, so that means it's going to come from above and go back up because our leading coefficient is positive. We have no double roots to worry about. That's about it. Okay, so as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to still infinity. So if I draw my nice little graph here, 1, 2, 3, kind of spacing this out because I know the values. Okay. I know we go through 0, 0. We go through 2.24, so right about there. 0. We go through negative 2.24, comma 0. And we go through negative 1.2, which is right about there. We know it's coming from above, so it's going to be coming down like this. It's going to come back up through here, go back down through there, and then come back up through there. It makes kind of like a W shape. And that should be our graph. Okay. Hope that helps. Oh, by the way, I need to point out that this height, this depth, and that height, and this depth, not necessarily to scale. I mean, it could extend, go way down and come back way up and go down, but that's just the overall shape. Okay. Hope it helps.